Okay, so the quiz from last time on um, working with Taylor series. So here was the question, and you had to follow the steps. Some of you try to go do something else, but that that doesn't work. That makes it you didn't complete the thing wrong. So okay, let's start off. So in step one, we had this series here, and I'll copy the series again. Some of you still get this wrong, so I'm gonna do it again. Instead of an X, I'm writing empty parentheses, okay? So this is what you get. Dot, dot, dot. There are more terms, but we don't write them. Okay, so what do you have to do? Well, we have to, you see here that we have to, we have an X square, right? So we're gonna plug in X square here, everywhere in these parentheses, because that's what it means, right? A parenthesis, a variable is a vessel in which you input something, and in this case the input is X squared. Now you have to work this out. Most of you this is correctly. Some of you still got this wrong, right? I mean, the power of a power is multiplying the exponents. Okay, that's x to the 6th, and this is 120 x to the 10th. Multiply, not adding. Okay, that was step one. Step two. Here again, some strange things happened, but so let me work it out. What we have here? Well, I wrote this. I gave you this polynomial, but of course that's a series, right? The polynomials are series. It's just a simple series. It's one without the dot dot dot, and you have to multiply this with the one that we just found, and it's multiplying. Some of you interpret it as if you have to plug in. Some of you interpret it as if you have to do some inverse. I mean, perhaps there are some examples in the textbook, but I never treated them where you have to take an inverse of this thing. But no, it's not nothing of that sort. You just have to multiply this out, work this out. Some of you FOIL it out, I mean, or distribute it, or that's fine too. And then, if you do that, somehow people seem to not notice that there are like terms and combine them. It's fine, you don't really have to, but it gets very, very messy and you have a lot of terms. So I'm going to do again the way that I would do this. I'm going to look at the possible powers that I can get. X squared, x cubed, x to the 4th, x to the 5th, x to the 6th, x to the 7th. I said the first non-zero terms, but you cannot really know when this happens, right? I now know that it's around here. But in principle, yeah, you don't know, so you have to really try out. Okay, so let's look at what are the possibilities here. Well, first of all, this is at least degree 1, this is at least degree 2, so nothing lower than degree 3 can happen. So these are definitely 0. The first one that happens is here, of course, the one that I just underlined. And that's the only way that I can get x cubed. X to the 4th cannot be made because with this x here, well, this definitely can never get x to the 4th, right? Because it's already x to the 5th. With this one, you need an x to the 3rd on the other side, doesn't exist. The same for x to the 5th, doesn't exist. X to the 6th. No, it isn't possible because, again, there's nothing on the other side that matches it, so also there. Now, x to the 7th, that's the first time when something happens. Or not the first time. So let's see what we have here. Let's do this I'll do x to the 7th here. So we have this x combines, this is an x and an x to the 6th multiplied to 7. Now we're adding exponents, right? So that's why x to the 7th we get here. And that is 100 minus 120 divided by 6, which is actually negative 20, right? But be careful, that's not the only term. You have to also check, what about this one? Can I combine this? Yes, you can combine it with this one. So you get plus 24. So that is negative 20 plus 24. So the whole thing here is 4. So that's a non-zero term. The 8th power is not possible. Let's look at what happens here for the 8th power. With this one, we need an x to the 7th, doesn't exist. For this one, we should an x to the 3rd, doesn't exist. So, okay. X to the 9th, same reason. If we would combine this with this one, we need an x to the 8th, doesn't exist, and the same for the next one. X to the 10th, same reason. There is no 9th power on the other side, and for this one, I need to be a 5th power on the other side. It's not there. So x to 11 is the next one. So let's see what we have now. Let me get rid of these underlinings. Okay, x to the 11th. This one, a power x, can combine with this power x to the 10th to give 1. Right? You multiply the exponents. So it gives x to 11, so you get a 1 there. But that's not the only combination. There's another combination. And what about this one? Yes, I can combine it with this x to the 6th. So we have now 24 times minus 1, 6, so minus 24 over 6, which is actually negative 4. So 1 minus 4, so that is negative 3. And now we have another non-zero, so these were 0, right? So yeah. So we have now 3 non-zero terms and we are done. Let's write them up. How do we know what it is? Well, this tells it you here. This is 120x cubed plus this one here is 4x to the 7th minus 3x to the 11th plus, of course, there are more higher ones, but we write dot dot dot. That was the solution for step 2. That was the step that many of you kind of faltered a little bit. And of course, if you get it wrong there, can be very messy, right? Some of you, as I said, would work out each of the brackets and then just combine everything, or not combine it, and then some of you had, like, instead of combining these two terms, kept them separately. It's just more work, and it's good a practice to always combine like terms. Okay, so now we had to integrate this, the one that we now just have, so x cubed plus 4x to the 7 minus 3 x to the 11th. Most of you did that correct, so this I'm going to go quickly over. So that is 120, add 1 to the exponent divided by exponent, right? Plus 4x x to the power 8 divided by that exponent minus 3 times add 1 to the exponent divided by the exponent plus dot dot dot, and this is between 0 and 2. Write this, remember you write this on the back, not in the front. I saw somebody do that. And now we plug in. Now I didn't insist on it. Some of you really worked it out, but I didn't insist on it. But let me show you how it would be. So the 120 divided by 40, that's 30, right? And then we have to plug in. That I needed you to do. 2 to the power 4. Plus, the 4 and the 8 cancel, so we have a 2 here. We have 2 to the power 8 divided by 2. This would cancel to a 4, so we get minus 1/4, 2 to the power 12, plus more terms, and then you plug in 0, but that of course is 0, which we should just subtract. And then, so let's work it out. 2 to the power 4 is 16, 16 times 30 is 480, right? Yeah, 480. This is 2 to the power 8 divided by 2, that's 2 to the power 7, which is 2 to the power 7 is 128, and then 2 to the power 12 divided by 2 to the 4, which is 2 to the power 2, is actually 2 to the power 10, so it's minus 1024 plus dot dot dot. So this would be, wait, did I do this right here? 16 times 30. Right? Yeah. And then this one 2 to the power 5, 6, 7. Yeah. Okay. So we get 608 minus 1024. That was minus 4016. Sorry. That was the answer. Of course, there's a dot 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 here, right? But the first 3 non-zero terms were added up to minus 460. But if you had it this way, that was already fine.